Hello, hi students. Today in this video we are going to see another topic based on Euclid division lemma from the chapter Real Numbers. So dear students, I expect your cooperation and attention here for in this class. First you should understand the format of numbers. So listen very carefully. So how we are going to describe this format? We are going to describe this format using Euclid division lemma, right? So at very first, we're going to take even numbers and odd numbers. How we define an even number or an odd number? Can you say? You know the answer, right? So some of you might have said in your mind that I know the answer. It is very easy. If you don't know about it, I'll explain that. If you are dividing a number by 2, then if you are getting a remainder 0, that the number is even number. If you are getting a remainder 1, that is an odd number, right? So let us take two examples and we can write the form of odd number and even number. Let us take two very simple numbers like 4 and 5 we are going to take. You know that which is odd and even number, right? 4 is an even number, 5 is an odd number. Let us divide by 2 and see, right? If we divide 4 by 2, 2 times 2 is 4. When we subtract, we get the remainder as 0. If we divide 5 by 2, 2 goes in 5 2 times. So 2 times 2 is 4, and we are getting remainder as
1.
So if we get the remainder 0, that number is even number, and if we get the remainder as 1, that number is odd number. Did you understand this? So let us write the format using Euclid division lemma. What does Euclid division lemma says? For any two numbers like A and B, then A should be greater than B. If it is like that, there exist unique integers Q and R, which means quotient and remainder. Q and R, they will be there. Which will A will be in the format BQ plus R. Now let us take 4 as A. Okay, 4 as A. And what is the divisor? We have taken 2, and the quotient here is 2, the remainder is 0. And for A is equal to 5, if you take A as 5, the quotient is, the divisor is 2, and the quotient also 2, plus the remainder is 1. If you take another two numbers, for example, if you take 6 and 7, if you divide 6 by 2, it goes 3 times, 2 goes in 6 3 times, and we subtract, we get 0 as a remainder. In the case of 7, if you divide by 2, we get the quotient 3, because 3 times 2 is 6. 2 goes in 7, 2 goes in 7 3 times. When you subtract it, we get the remainder as
1.
Okay. Let us take these two numbers. Since 6 is an even number, we write here. The divisor is 2, the quotient 3, the remainder is same. If you take 7, 7 is odd number, so we are dividing by 2, and the quotient is 3 plus the remainder is 1. If you observe, the divisor here is same, that is 2, and the remainder for even number is 0, and the remainder for odd number is 1. So follow this. But if you see that the quotient is changing 2, and here we are getting 3. If you select another number, for example, if you take 8, the next even number, we can write 2 into 4. 2 times 4 is 8 plus 0. If you see, this quotient is changing. If you select another number, another odd number, the next odd number, here also we can write, it is 2 times 4 is 8, the remainder is 1. 2 times 4 is 8, 2 4s are 8, plus 1, 9, right? So here also if you see that, the quotient is changing, right? We can write a common form of even number, and for even number and for odd number. For even number, we can write any even number can be written in the form of 2 into, this is changing. Instead of this, we can write a variable. Why we are using a variable here? Because this value is changing, varying, right? So we can write a variable here as m. Why m? We can write any alphabet from A to Z, but it's a common practice here in this Euclid's division lemma to use a m or q as a quotient. So we can use any number, any alphabet, but we are using m or q as a common practice. Then plus 0. Since it is a 0, just we can avoid. So we can write as 2 into m as 2m in short. So what is the format of an even number? Any positive even number can be written in the form of 2m or 2q. Or we can write as 2q. 2m or 2k. As I said, either we can write m or q as a common practice. Okay. So next we can take the odd number. In this one, the same way we can write as a is equal to 2 into m plus 1, because we are having the remainder as 1. So in short, we can write as 2m plus 1, or we can write as a is equal to 2q plus 1. Don't be confused. Either we can use m or q. Both letters we can use. You may ask a question, why we should use m or q? Can't we use any other alphabet? Yes, of course you can use any alphabet. You can use a different alphabet for it. But a common practice we are using with us. Understand that it is a common practice we are using m or q. Don't be confused with that alphabets. Try to understand and keep in your mind that this is the format of it. So far what we have understood, what we have learned that we can write positive integers in a sum format. Okay, in that we just learned that we can write even positive integers in a form as 2m or 2q, and we can write odd positive integers as 2m plus 1 or 2q plus 1. Let us see one question based on our understanding. The question is on the screen.
Show that every positive even integer is of the form 2q, and that every positive odd integer is of the form 2q plus 1, where q is some integer.
So let us see the answer of this question. What is given? we have to show or prove that what we have understood in the earlier session. So we should prove that every even integer, positive even integers can be written in the form 2q, and every odd positive integers can be written in the form of 2q plus 1, right? This we are proving using Euclid division lemma. In the Euclid division lemma, what it says, if there is two numbers a and b, there exist unique integer q and r such that a is equal to 2q plus r. എയും ബി എന്ന് പറഞ്ഞ രണ്ട് നമ്പേഴ്സ് ഉള്ളപ്പോൾ there exist another integers quotient and remainder. We can write that in format of aq. A is equal to bq plus r, right? First, what are things we need? A, b, q and r, right? First we are assuming that a be any positive integer. We are assuming a as any positive integer, and we are assuming b is equal to 2. Why b is equal to 2? Because to show that a number is even, we should divide it by 2, or odd, we have to divide it by 2. So the division we are doing by 2, so b is equal to 2. B is the divisor. By Euclid's division lemma, these so there exists q and r, right? That already I said it. So we can write such that a is equal to bq plus, instead of bq plus r, here b is equal to 2, right? So a is equal to 2q plus r. Okay, where r is less than or equal to 0. So r value, it is less than or equal to 0, less than 2, right? As per the lemma. So we can write that is the r value either 0 or 1. Either 0 or 1. So we can apply here, substitute the r value. First, if you substitute r as 0, so we can write 2q plus 0. We can write further, we can write as a is equal to 2q. If you substitute r is equal to 1 in this place, we can write as a is equal to 2q plus 1. If it is a is equal to 2q, it is an even number. That is why if a is equal to 2q, then it is a even number. If a equal to q plus 1, that is a odd number. So we have proved this by Euclid division lemma. Using that only, we proved that the format or form of an even number and odd number. Finally, we can write as every or any positive integer, positive even integer is of the form 2q, and any or every positive odd integer is of the form 2q plus 1. If you did not understand, you can play back the video and just watch it again. Hope you understood. If you have any doubt, don't hesitate to call me, and I can clear it because I'm available always for you. Thank you for watching.